Okay, so we are going to start our very important concept, exam point of view. Please, Young's double slit experiment, and popularly we say YDSE. YDC. Okay, so what is Young double slit experiment? What is it about? Anybody who knows can tell me something vaguely. Who remembers? Who studies? Who has studied already? अद्वैत क्या है? अद्वैत क्या है? Khalid, what is it? Khalid, what is it? What is Young double slit experiment? Nobody remembers, sir. Seriously, nobody knows. हर्ष क्या है? सिद्धि क्या है? एग्जाम लिखने जा रहे हो यार, कुछ तो पता रहेगा.
वो लाइट को पास करते हैं दो.
लाइट को पास करते हैं? किसके? कहां पर पास करते हैं? Okay, guys. So there is a scientist called Young's. The scientist called Thomas Young in 1700, 17th century, I think 1780 or something. What did he did an experiment. Okay, he did an experiment. What was the experiment about? What he did, he took a source. He took a source. It's called coherent source. Okay, and he put a convex lens. He put some kind of pattern, some kind of board wherein there was two slits, openings. छोटा छोटा opening था. Whole cardboard was filled. Only this part was open. Okay, open. And he put a screen here. And moment he put the light went, and obviously convex lens converges. It became a coherent source. It passed, and here he saw now. Is it not really surprising? Here, ideally, what should have happened? If you put two light in screen, also you should see like this. Only these two light. Yes or no? Do you agree with all of you?
Yes.
But no, it is not so. It is unique. How can it happen? He was like completely. He was surprised. How it can happen? I said there are two slits, S1 and S2. Light passed. So ideally we should get like this, but it did not happen like that. It happened like this. Why? Why? That was all about the theory that it is not going straight. Light is no more going straight. We studied ray optics. Light goes in a straight line, but no more the light is traveling in a straight line. No more the light is traveling in a straight line. Then what happens then? So now we'll study. This is the convex lens. This is the slit 1, slit 2, this screen. And so what is this? We say this as fringes. What is say? Fringes. This is called a light fringe, and dark fringe. So alternate patterns of light fringe, bright fringe, and dark fringes were obtained. So I am considering this as light, by the way, dark as light. So this is light, this is bright fringe, this is dark fringe, bright fringe, dark fringe. So this was his conclusion. This was the outcome of the experiment. But why did it happen? Why did it happen? What we're going to study. Okay, so write down a point, all of you. The fringe pattern shows that light has a wave nature. Light has a wave nature, and and bright fringes bright fringes are the result of bright fringes are the result of constructive interference, and dark fringes are the result of destructive interference. Clear? Yes or no?
Yes, sir.
Clear, all of you?
Yes, sir.
So now let us rub all this. Now, see, ideally I should get two lights. Yes or no? Two lights, correct? So now this opening, this slit opening is so small. It is very small. It is maybe thinner than a hair, or maybe it is like a hair. It is so small. The thickness can be compared. The thickness of the slit opening can be compared to the wavelength of light. Okay, and this outcome happens only when the slit is comparable. That means the opening of the slit is comparable to the wavelength of the light. But if you are enlarging it, if you make it big, then this will not happen. It will be normal. It will be normal. You'll get two light. That's it. So the beauty is, what is happening when we make these slits very small? What is the magic happening that this slit is becoming very small? Now, remember, now recall the Huygens principle. What did we study in Huygens principle? What did we study in Huygens principle? Caroline, what did we study in Huygens principle? Yeah, tell me, what did we study in
Light
Huygens
is a
principle?
mechanical wave and it requires a medium.
And what else? Light waves are point sources, correct or not? Point sources.
Yes, sir.
So when you are reducing the slit, we are trying to understand what is happening, why this dark and bright fringes are obtained only when the slit thickness is very, very small. So what happens when the thickness are become less? It is acting like a point source, like a point source. It is very small, very small. Each is like a point source. Each is like a point source. That means each of the sources are generating what? Waves or not? Yes or no?
Yes, sir.
Huygens waves. Each of the waves. So basically, if I want to simplify, I can write as, let's say I am talking about 2 point sources. One is one slit here, one slit here. So I am telling this one is generating this point, it is generating here, and here it is here. Here it is here, here it is here. So these light waves are what? Are interfering. So that means the light which is supposed to be traveling straight is not traveling straight. It is traveling as a wavelets, as a wave, like a ripples in the water. I told you previous class. When you drop a pebble on a water, it goes like a ripple. Clear? That means something is happening something is happening that no more the light is following a straight line path, it is following a normal wave. And this experiment proved that light is a wave. Clear? Clear or not?
Yes.
Yes, sir.
Okay. Now, whatever we saw, let us see as a simple diagram like this. Let us say this is S1, this is S2. I am seeing from where? I am seeing from the top. Okay, I am seeing from the top. Basically, how it is in a board, it will be like this. If I see from the top, if I put my eyes top, it will be like this. What we are seeing. Clear? This is called the aerial view or the cross-sectional view, whatever. So I have a screen now. So now light coming from here and the light coming from here. I told you the light waves are happening. So these two light waves at the middle, middle what I got? Dark fringe or the bright fringe. I got a bright fringe. Here I got a bright fringe. How? I am supposed to get light here, but I am getting a light here. How? Because the light wave here and the light wave here are both merging. That means this distance and this distance is what? Same. This basically, if you say this is a what right angle triangle or not, this distance is a hypotenuse, this also is a hypotenuse, because the slit are equally they're put. If whatever different this is the same is the length. Okay, so this distance and this distance are same. And now whenever I told you, whenever the distance is same, the part difference is same, what you will get? Constructive interference. Clear? Clear or not?
Yes, sir.
That means whenever the part difference is same, you are getting constructive interference. Now, similarly, let's say there are two waves which is going like this. Now let's say here one wave is going, and from here one more wave is going. Now you tell me how it should be. Here what it should be? Destructive or constructive? What it will be? Part difference are different or not? Yes or no? So like this, that's why wherever the light is not there, wherever the destructive interference is there, you are getting a dark fringe. Wherever there is a constructive interference, you will get a bright fringe. And this is all happening because light is no more traveling straight line. It is your secondary wavelets are also acting as point source. So this point source will generate here light. This point source will generate here light. This point source will generate here light. So it is going like this. The light source is going like this, and wherever the two are constructive interference, this will generate a what? Bright fringe. Wherever the destructive, it will generate a dark fringe. Clear, all of you?
Yes, sir.
Yes, sir.
So what are the condition? Now we'll come to the maths of this. Everything is fine. What are the maths of this? The maths is the distance between the slit and the screen will be greater than D. What is D? What is D? Slit width. It's called slit width. So this is the slit width, small d. Okay. What is the distance between two slits? This distance will be very, very smaller than this distance. Maybe this distance will maybe of some 50 meter. Okay. But this distance is maybe some 1 centimeter. Obviously, 50 meter is very higher than 1 centimeter. Yes or no? Yes or no? 50 meter is how much? 5,000 centimeter. Yes. So 5,000 centimeter and 1 centimeter is very, very high, no? So this will happen. That also, there are multiple things. First of all, the slit has to be very, very small. You cannot make it very big. It has to be very small, thin. Next, the distance between the slit and the screen will be very, very high than the slit width. This is called slit width. And this distance is between the screen and the slit. Clear? Clear or not?
Yes.
Yes, sir.
So So if I say, if I write down this one like this, and here I will have a screen. I have S1 here, I have S2 here, okay, and this is obviously the D, and I am focusing that light waves. This is the center. Okay, this is a point P, and this is the central part of the screen. The distance from here will be Y. Okay, and let's say, so now tell me, if I take a perpendicular, draw a perpendicular on this, that means what? If this is S1P and S2P, if I take the difference between this one, S1P and S2P, the difference between these two distance is what? The path difference. That means this S1P is what? Has traveled further, more travel. That means the difference between this distance is called the delta x. That is called the path difference. Clear?
Yes, sir.
S1P is more or S2P is more? No, S2P will be more, no? Yeah. S2P minus S1P. So this distance, this ray has traveled more distance than this distance, this ray. So this distance, so the difference between these two will be this small distance. That is called the path difference. What is called? The path difference. Clear? So if I take a point Q here, I can tell the S2P minus S1P as what? S2P or not? This distance is what? S2P or not? Clear?
Yes, sir.
And what else? This angle will be some theta. This is 90 degrees. This will be some theta. Clear? So can I write? So if I enlarge it, how it will be? It's not looking like perpendicular. With this theta, this also become 90 degree. Now this will be what? This I told you. This is D. This distance is S1, S2, P. Clear or not? So what will be sine theta? What will be sine theta? Sine theta will be perpendicular by hypotenuse. What is perpendicular? This is the perpendicular, no? Correct or not?
Yes, sir.
So it will be delta x by, this is the hypotenuse, D. Understood? So what will be your path difference? Your path difference will be D sine theta. Clear? Yes?
Yes.
Okay. So what we saw for the first fringe, you remember I told you, first fringe, first maxima is what? Delta x should be equal to lambda. Constructive interference. Remember constructive interference. What was, it will take values as lambda, 2 lambda, 3 lambda, 4 lambda, 5 lambda. But destructive it will take what? Lambda by 2, 3 lambda by 2, 5 lambda by 2. So delta first will be lambda. Yes or no? First will be lambda. Next will be 2 lambda. Correct? Am I correct or not?
Yes, sir.
So your delta x will be what? Lambda. So for the first fringe, first bright fringe, you will get what? Maxima. Delta x will be lambda. Now we already found delta x equal to d sine theta. Then can I write this was as d sine theta equal to lambda? Yes or no? So when I say our delta x was what? N lambda. That means for n equal to 1, this is n equal to lambda. So for the second will be what? D sine theta will be what? 2 lambda. because n will become 2. Second one, n equal to 2 here. Here n equal to 1 here. Am I correct? Am I correct? So can I write this was as sine theta as what? N lambda by t. Correct? Yes or no?
Yes, sir.
Yes, sir.
Hmm? So now we will do a small. So remember, what is lambda? What is the order of lambda? Any unit? It will be in angstrom. In 10 to the power minus 10 meter, because the wavelength of the light is very, very small. Yes or no? It will be order of 10 to the power 10. But what will be the order of d? Distance, the distance between the two slit width, it will be order of millimeter, or maybe millimeter to 1 centimeter. Yes or no? So if I say your d is very, very larger than lambda. Yes or no? Because your lambda will be 10 to the power minus 10 meter. But what about here? Millimeter. It will be 10 to the power of minus 3 meter. So obviously your d will be very, very larger than lambda, or not? Yes or no?
Yes.
Okay. So we are making a small assumption. If theta is very small, your sine theta also will become what? Tan theta. Sine theta becomes tan theta. Okay. Okay. Why did we do this one? I will explain you. See, this was P, and this I told you what? The distance between this is D, and this is the middle. I'm considering this is middle, by the way. Sorry. So this will be what? Y. So now the angle, the angle between this one is theta, because see this angle, this is theta. If this is theta, this is 90. What will be this one? 90 minus theta or not? This angle is theta. This angle is 90. So what will be this angle? This will be 90 minus theta or not?
Yes, sir.
So, but you know this whole angle is 90. Am I correct? Slit and the middle, it is 90 or not?
Yes.
So if this whole angle is 90, this is 90 minus theta. What will be this one? Theta or not? Correct?
Yes, sir.
So if I take tan theta, your tan theta will become what? Tan theta will be what? Y by d or not? Y and d or not? Perpendicular by base.
Yes, sir.
Base is d. Correct? Yes? Yes or no?
Yes, sir. Why right?
So I told you, if sine theta is equal to tan theta, then what was the sine theta? Our sine theta was lambda by d, small d. So lambda by d will be very, very equal to what? Y by d. Yes or no? Lambda by d is equal to y by d. Am I correct? Am I correct?
Yes, sir.
So can I write y will be d lambda by small d? Yes or no?
Yes, sir.
So here I had n. Why did I miss n? Because that's okay, because we are considering first spring. So you can add one here also, n lambda. So it will be d n d lambda by d. This is a generic formula to find out what is the fringe width. So what is this y? So what is the formula we got? We got the formula as y is equal to n d lambda by small d. What is y? It is the distance. Write down. It is the distance of first bright, okay, from center. From center. That means I have a screen. If this is the center, the first bright, this is the bright one. First bright. This is the y. Okay. This is the second bright. This is the third bright. This is the fourth bright. Clear? So if n equal to 1, then it will be what? D lambda by d. This is this distance. If n equal to 2, then what will happen? You will get this distance. If n equal to 3, you will get this distance. If n equal to 4, you will get this distance. Similarly, it will be this side also. Here also 4, here also 4. Equal spacing, all equal spacing. Clear, all of you? Clear, all of you?
Yes, sir.
Okay. This is called the central maxima. This is the first bright maxima. Central maxima, first bright maxima. So this distance is between the central maxima, IC you can call it. NC, let us see. Why? Because if n equal to 1, then it is the distance between the first bright central maxima with first bright. If n equal to 2, it is a distance between the central maxima with second one. If it is y equal to 3, it will be this one. This one. Clear? All of you clear? Clear or not?
Yes,
Yes,
sir.
sir.
So you can consider, right, the YNB equal to ND lambda by D. That's all is the formula. Okay. Now this is for bright. This is for bright. But what about dark? You have dark patterns also, no? Interferences. You got alternate dark and bright patterns. Am I correct? Am I correct?
Yes, sir.
Yes.
Then what will happen? What was our formula? What did we start with? We started with delta x equal to what? Sine theta. No. Delta x was what? Our first was delta x was lambda. For what? Bright. But remember, for destructive interference, this is for constructive. For destructive, what did I told you? Lambda x equal to 2n minus 1 by lambda by 2. Yes or no? Yes or no?
Yes, sir.
For first dark will be what? 2 into 1 minus 1 by 2. It will be what? 2 minus 1 by 2. It is equal to 1 by 2 lambda. That means your first dark pattern will be lambda by 2. Your first bright was lambda, delta x equal to lambda. This for bright. For dark, it was here also n equal to 1. It was delta x equal to lambda by 2. For n equal to 2, it is what? Delta x equal to 2 lambda. Here it is what? Delta x equal to what? 2n minus 1. 2. 4 minus 2, 2 into 2 is 4. 4 minus 1 is 3. So it is 3 lambda by 2. N equal to 3. It was what? Delta x equal to 3 lambda. Here it is what? Who will complete me? Complete it. 5 lambda by 2. Clear, all of you? Clear, all of you?
Yes, sir.
Yes, sir.
So for delta x, so we got the formula for bright, for the dark fringe. For the bright fringe, we got the formula. But what about dark fringe? So for the bright fringe, what we got? YNB equal to n lambda d by d. We'll complete the class in another 5 minutes. Okay, because too much bombarding. So delta x is what? Lambda by 2. So what is delta x? Delta x is what? D sine theta. So d sine theta equal to lambda by 2. Then what will be sine theta? Lambda by 2d. For bright, it was sine theta was what? Lambda by d. Here it is 2d. Yes or no? And tan theta was what? What is tan theta? Y by d. Yes or no? So sine theta equal to tan theta. So lambda by 2d equal to y by d. Yes or no? So what was our dark fringe? ND equal to what? What? Who will tell me? 2n minus 1 d lambda by 2d. No. N only. N is there. N d lambda by 2d. Clear? Clear?
Yes, sir.
So you can find out. So 1 minute. I did a mistake. Wait. Because if n equal to 1, then 2 into 1 is 2, 2 minus 1 is 1. So it is correct. No, we are supposed to get what? Y should be d lambda by 2d. Oh, 2d is there, no? Correct, no? Yeah, this is the formula. So for dark fringe, it is, for bright fringe, y nb was n lambda d by d. And for dark fringe, it is 2n minus 1 d lambda by 2d. Only difference is what? Here n, here 2n minus 1, here d, it is 2d. Clear? Clear?
Yes, sir.
So we'll continue. We'll continue in the next class, Wednesday's class. We'll complete this and then we'll move ahead. We'll do some problems also. This is very, very important from exam point of view. I'm saying you. Now only I'm telling you. Okay? All of you?
Yes, sir.
No doubts?
Okay, sir.
No doubts, no?
No doubt, sir.
Advait, clear? Make your internet connection proper, by the way. Okay. Okay, guys. See you then. Good night, all of you. See you on Wednesday. Yeah.
Thank you, sir. Thank you, sir. Bye, sir.